with the development of the new reactor, that makes a lot of the things, even in the USB stick given to governments, obsolete.
Okay, can we start? Maybe we could start with if someone from the Chinese sector that can understand the words I'm saying and can communicate back might have a question for Mr. Keshe. Is there someone there that would like to start out?
I can see that they are trying to write some text, so if I could read the text, I can translate it for you. Meanwhile, Mr. Keshe, I have a question for you. The email that I sent to you within the last week or so contains some very interesting idea. Please try to...
Oh, it's the one, excuse me, is this the one you're talking about, the measurements and the idea by the vortex?
No. It's about the Marco Rodin, the vortex-based mathematics, and also...
Yes, I read that. It doesn't make sense to me.
Oh, and also there's a coil called the Eppard coil, which has some very interesting properties.
But the thing is, we don't use coils.
Yeah, I understand. You don't use coil, but what I'm suggesting is the property can probably help in the design of the reactor. That's why I suggested to you. Anyway, if you have
those two emails you said I've seen. I looked at it and I've seen what you're talking about now. I understand. No, there is nothing we can do with it because we designed something very close to this about 2 years ago, and the dynamic of the plasma does not allow the use of the coil.
Okay. Now this coil is very different. I enclose some links for you. Please take a look at the experiment that other people did. They are not trying to...
I look, Mr. Cole.
Did you see the one with the spinning steel ball?
Yeah, I've seen, because we had to design totally a new coil.
Yeah.
It does not work. Somehow the plasma doesn't respond to this kind of thing.
Oh, okay. Got it. Okay. So let's see if they have any other questions.
So I guess what Mr. Keshe is saying, or to just reiterate that, it seems like coils, or whether it's high voltage, high frequency, or any other types of coils, magnetic coils and so on, are just not used with your system, Mr. Keshe? Would that be a...
No, because you have a DC structure, plasma current flow, so you don't have the, what do you call it, what you need to extract. And secondly, these dynamic magnetic fields do not respond that much to a coil. This I explained in one of the papers regarding power generators, which is part of the book 6. The power generators, when you use them as a receiver, as I explained before, behave totally different than a normal generator.
So, for example, we've seen the Chinese animation video. They have a coil of copper wire inside the inner core of the reactor. Would that not be a way to extract the energy from the reactor? Wouldn't be a good way to do it?
No. Put it this way, somebody can try. We spent nearly 6 months, 8 months designing a coil specifically for these kind of reactors.
Mm-hmm.
And it was literally designed from scratch by the specialist. It weighs nearly 6-7 kilo.
Mm-hmm.
And it does not do so. No, it seems, it doesn't seem, but the behavior of the plasma does not allow usage of coil.
Mm.
Actually, our coil is like a helmet,
Right.
and
I
so
think
we
I think
can
you showed a sneak peek of it a little bit in one of the videos of
presentation.
the past. I'll let people have to search that themselves to find it.
It's a three-phase coil,
It's
which considers every direction of flow of plasma. It could be because we consider plasma flows. We were measuring the two of the poles, two of the windings, to see the alteration during the plasma polarity change, because the change of polarity in the coil is like the planetary system happens through the flow of the current. So we were trying to measure the flow of the current from one direction to another for the confirmation of the change of polarity. But these coils are very, very difficult to produce, and they do not seem to be responding to DC flow of the plasma.
okay. Well, that's good information.
We don't know. Others have to try, but this is our trial test case.
There are some folks that subscribe to the school of stimulation of the plasma environment by a certain frequency that might be a harmonic, for example, of the Compton frequency, which is the frequency of the electron, that it might be able to vibrate like ion pairs or something like that in the plasma in order to activate it with certain catalysts and so on.
When you have a plasma, we did a test 2007, 2008, and again in 2009, 2010 to monitor the interaction of external fields on the plasma. There seems to be some effects on the speed of the motion of the plasma, but depends how you introduce this external field. And very much dependent on the strength of the field you introduce as well. I see any questions. This in your reactor. Are all your gases separated and stay in their only chamber? What does this mean? Can somebody try to explain this? All the gases stay in the chamber, but you can play games with the chamber, with your gases. We done this test before, where, for example, you go in 4-layer gases, and due to the dynamism of the plasma and the speed of rotation, you can extract the outer layer or the inner layer gases as you need. It's a very interesting effect if you can do it, but you have to know what you're doing. So, for example, you can extract the nitrogen layer totally, whatever is left of it, during your trial, during your test, and go and allow the helium to take over to do the same function.
What do you mean when you said extract?
There are ways of extracting gases during the operation. You have to develop it, where you depends how you use the gases in your reactor. If you use them for ionization, once you use the gases for the ionization, you don't need them in the chamber anymore. They become a burden unless you use them for blanketing. So you have to develop within your reactor a parameter or apparatus where you can extract the nitrogen from the outer layer or even whatever gases you have. The gas layering, once you start learning how to play with it, will give you a lot of flexibility. But on the other hand, you have to understand the measure of the gases you've introduced, how much of it is being used in the chamber, and how much you extract. And if you have a system to measure what gas is coming out of your core, then you can use layering of gases for expansion of the plasma inside. This is part of the technology of developing materials.
Okay. So when you said extract, you mean to suck it out, to
Yes,
draw it out
yes,
from?
yes,
Okay.
you can do. Yes, yes. This is part of the flexibility of the center chamber. If you can use like a center chamber with different facilities, and the central column, if you use it, a flexible central column, you can literally dig into where you want to be. This needs a lot of experience, and from what I've seen, especially with the Chinese setup with the gas measurement tools they have, this should be very, very easy. They know what they use. They can measure the thickness of the layer, and at that layer you open your chamber to suck the gases out. And this allows the expansion of the plasma. In the space technology, you use the expansion of plasma for rapid reduction or increase in gravitational fields.
Altering the thickness of the gases inside the reactor. Is that what you're saying?
Pardon?
By altering the thickness of the plasma gas inside the reactor, you can change the gravitational field.
In very advanced cases, yes. I've done it before, and you can do it because the expansion of the plasma creates different gravitational field strength. You don't need to keep on extending it, but you can do the same if you use a double core. There is a misconception about the behavior of plasma in layering. Plasma, even in layers, has different gravitational magnetic field strength. This is how the stars operate. The stars, the magnetic gravitational field strength, it comes by the layering, and the thickness of the layer. So, in fact, as you create gas layering in your reactor by, let's say, nitrogen and carbon or hydrogen, whatever you might use, the same thing happens, the same layering happens according to gravitational magnetic field with the plasmas. So if you understand what you're doing with your reactor, so you can create a plasma layer with different magnetic gravitational field, and then the next layer different, and the interaction of these two layers or 2-3 layers will give you a very powerful gravitational magnetic field of the system. In the star system, when you look at the structure of the star, there is no physical layer separation. The layer separation is gradual, but it's magnetic gravitational field, the strength of the plasma, which creates the layering. It's not the gases. The gases is in a matter condition. In the plasma condition, you literally work with the layering according to gravitational magnetic field of the plasma. And this effect allows such a powerful gravitational magnetic field behavior as we see from the stars, because the layering internally allows a different interaction, and this increases, reduces it. This is I'm just writing something for you that I can explain. So the way you create layering with gases, you create layering in plasma according to the gravitational magnetic field strength. This is an advanced, very advanced reactor control system, and then you play a different ball game. These are highly super efficient, and in layers, and according to the strength of the gravitational magnetic field of the plasma layer, you can produce materials in each layer or extract what you need. This I have done a few times, and it was the backbone of producing gold in a reactor. Because when you want to produce like water or hydrogen, you go to the outer boundary layer of plasma. If you want to produce gold or heavy materials, you go in a higher strength layer of plasmas. Then you can dictate where the layer sits. This needs a very deep knowledge of plasma technology. And I have explained partially this in the book number 4, which will be published soon, I hope. So the same way as you control the gases, gas layering, you can control the plasma layering. The same concept is you have up to now, I see a lot of people speak about nitrogen to create ultraviolet or extreme ultraviolet for ionization. But in reality, you can do it in a much, much, much easier way if you use helium. Helium, in a certain condition in the chamber, allows you to create ionization and reach a faster plasma condition. So when you speak about nitrogen, the outer layer, yes, nitrogen is used in a matter level, like Earth. On the upper layer of the atmosphere, we have nitrogen, which creates this extreme ultraviolet condition for creation of different materials. But in the structure of the solar systems, in the structure of the stars, in the center, the same ionization is achieved by helium. The only problem is that the present nuclear physicists, especially in the fusion industry, they consider that in the center of the stars, helium is created through the fusion of hydrogen atoms or hydrogen plasmas. But in fact, helium is a byproduct of the radiation reduction. And that's where the whole misconception with the fusion is. So, in reality, you can change your layering from hydrogen, helium, oxygen, carbon, carbon, oxygen, and nitrogen to a direct hydrogen-helium. But triggering helium, it's much easier than nitrogen to release extreme ultraviolet to achieve ionization. So then you can play different games with the helium accordingly to making layers. And this is what I do usually with my systems. I see a lot of people use nitrogen, or they speak about other nuclear or what I call ionization radiation level of heavier than nitrogen. In fact, we can do the same thing with two gases. In the chambers, you only need two gases to create your plasma. And then you can play very interesting games, but I've seen people using three, four. It's good because you create a condition to use what I call blanketing. But if you design your reactor originally in a specific way, you do not need heavy gases. You can operate the way I do with helium and hydrogen only. But that comes out of experience. The video we looked at with the Chinese development last week with Mr. Cho, it's very interesting. But this reactor needs gas layering, at least 3 to 4 layers to achieve what they want to do. And then when you work with so many gases, you have different factors. If you go to krypton, it gets worse. So you design your reactor from the beginning, from initial stage, for two, two gas combination. And this gives you a lot of flexibility. This gives you a lot of advantages in operation of this system. You don't need to go heavier. I use carbon. I used to use carbon. I used to use nitrogen. But when I use nitrogen now, it's for a specific purpose. If you look at the Chinese reactor, if you look at the Polish reactor, these reactors are very, very interesting monoplasma reactors. These can be used for what I call the star system. But for prototyping and for experimenting, these are very hard reactors to control. First of all, you have to create a dynamic condition in the plasma where it doesn't exist in both systems I looked at. Then you have that enforces you to bring external magnetic fields or creating dynamic fields where in fact the rotational motion of the plasma through plasma strength layering creates a dynamic position itself. So you don't need the creation of layering and then introducing different kind of motoring to create a dynamic plasma. Initially, you might have to do. So the response to this separating the gases in the chamber, try to design your reactors in a way that you only need two gases. You can still do the same thing with hydrogen and nitrogen without the helium or carbon in between. But then you have a high ignition problem. The high ignition problem is that you find when you open your reactor, you have bursts of burns on your reactor. You see it. You see it like when you put a match to a wall, you see the black spots on it. These are the problems with the nitrogen.
Mr. Keshe, in that, along with that question, I was considering getting nitrogen gas, and you can get it with, say, 2% hydrogen in it. It's considered non-flammable, and it's kind of a safe gas.
It's too high.
But when it would be, it should be much less percent to start with, even with those two gas combinations.
There is a company called what's their name in Europe. They are well into the gas mixtures. You can ask them any mixture you like, they make it for you. So you pre-order your gases.
So normally it would be much less hydrogen percentage. is the way I understand it, I guess. But I figured if starting out with maybe 1% or 0.1%, and then having a rotating structure with those two gases, then the hydrogen should be at the very center core, and it would be a small ball of hydrogen there compared to the nitrogen around it as the insulator.
Yeah, but the thing is, if you're using technology to trigger the release of EUV, the nitrogen atoms close to the hydrogen will absorb most of the radiation. The ionization will become very difficult.
Okay.
There are talks, people talk about using radioactive gases. You can use radioactive gases, but these are just to reach ionization. When you use high concentration of nitrogen, the way you speak, 2% hydrogen, is a fantastic idea. It's very good if you can do it. Then you have to reach a point to extract the outer layer of nitrogen to make the layer very thin.
Okay.
This allows the expansion of the hydrogen atoms, like, in the gas, the room becomes bigger, so you get the thing mixture correct. Then you can use very soft radioactive gases in the outer layer to trigger extreme ultraviolet in the nitrogen. Sometimes you can do with external pressures, but this is very, very technical. If you can do it, it's very, very technical how to create and control that layer.
What about the idea of using external rays such as X-rays outside of the core of the reactor?
It depends on the thickness of your material, of the core.
Right.
Most of the radiation gets absorbed by the material.
But wouldn't you only need enough to get through in order to activate the core hydrogen rather than to have to keep it going all the time?
This is you talking about the lasering. Lasering technology in reactors is very interesting, but again, this is very advanced technology.
It's like trying to hang on to a slippery fish or something. It seems like a pretty hard
No, because you have to be able to target it, and what you put as a laser, how much does it arrive at the interface between the two gases. You need the ionization, extreme ultraviolet, on the interface between the two gases. This is the reality, but when you work with plasma. And secondly, you can expand the size of the hydrogen plasma in a very easy way by I explained this in a talk some time ago. If you put air in a balloon and close it, then put this balloon in a chamber.
This is so funny, Keshe. You won't believe this. You won't believe this, but we have a demonstration that we're just about to get ready of exactly what you're talking about.
Yeah, but so what happens if you change the gases, the external, or put this balloon in a chamber, and you increase or decrease the pressure and the condition in this chamber, you find the balloon expands or reduces. The same thing you can do with a plasma. But it depends how much control you have the outer layers or equipment outside.
Right, exactly.
So if you learn that, you go to the plasma section. You go to the plasma, and plasma will create the same thing. Can we answer another question, or is it a second question? it says, please tell me the method of the excitation reactor. What does that mean?
I think what he means is how do you excite it? How do you excite the gases?
No, he means how to activate like a reactor.
Who's the lady?
How do you start the reaction?
Yeah, Mr.
The
Keshe.
reaction, initially, we used to use radioactive material.
Mm-hmm.
But now, in the new reactor which has been developed, we are bypassing that. Actually, maybe I can make an announcement. Not make an announcement, I can tell you today, now is the last days of June. The non-nuclear reactor of the foundation is literally ready for testing. So in the coming weeks, we will release a lot of information about the non-nuclear technology, where it allows people to develop the technology without getting involved with the governments and getting entangled with handling nuclear materials. This is how we run into problems, and a lot of governments try to stop us and calling all sorts of things regarding Iranian nuclear technology. And with the new reactor, it's more or less a matter of days before the final setting. And if it responds correctly, then we will disclose the date of the testing for some people to be able to be there to test or be live testing.
That's great news. Thank you very much. That's great news, Mr. Keshe.
You're welcome. We showed the reactor on 21st of April, but there was some technical problem which had to be rectified. We had to redesign new parts after the initial setting. But if the system responds correctly with the new, new setting, then we will release the technology as a non-nuclear, which means allows most of you to produce material or produce reactors which the governments, first of all, cannot block because now it's non-nuclear. Secondly, it's much safer for use. This way, you do the ionization ignition through totally different concept. A lot of understanding should come from the boundary of the Earth. In the upper atmosphere, we do not have nuclear materials which allow the nitrogen to release the extreme ultraviolet for the creation of matters. This is done through a specific condition, and so what we are doing, we're creating that condition in the reactor, where non-nuclear material allow the ignition or the release of extreme ultraviolet in nitrogen or helium. So you understand very rapidly that ignition does not necessarily mean using, as I've seen on the forum, the use of radioactive materials. There are no radioactive material in the upper atmosphere. It's the condition which allows the release of extreme ultraviolet from nitrogen. And if you look at the structure of internal structure of the solar systems in the stars, what I talked earlier on regarding the creation of helium, or what they say will release a lot of energy, which is total misconception about the fusion. The interaction or the reduction in the energy of the plasma leads to creation of helium, and the purpose of helium, creation of helium in these layers in the structure of the solar system, in the structure of the stars, is to release extreme ultraviolet that never hydrogen atom is created to shut the system down. This is a total misconception in the world of nuclear technology. So what you call a fusion, creation of helium, that is created out of fusion of the plasma, this is totally wrong, because the slowdown of the gravitational magnetic field of the plasma. So this leads to the creation of helium, and helium is not in a matter state helium. It's very much in a gas state helium, and is in a gas state. So that helium, by releasing extreme ultraviolet, never allows the atomic hydrogen to be created in the center of the star. That it shuts it down, because once it becomes an atom, then you have matter. So the whole misconception is that hydrogen fusion leads to creation of helium, and that will be the magic technology of the energy. But the physicists never understood this concept. And so they have developed programs and technologies that it says that hydrogen, plasma fuses, and then helium is created. No, helium is created by reduction in the magnetic gravitational field of the plasma itself in different layers. And the job of this helium, which is created, is not out of fusion, it's out of reduction. And its job is to make sure, by releasing continuous extreme ultraviolet, that no atomic hydrogen is created. So part of the helium you use and nitrogen you use in your reactors is not to create ignition, but it's to make sure that as the plasma is giving you hydrogen, what do you call it, gravitational magnetic field, or magnetic field that you can use for creation of gravitational magnetic field for movement or energy, these do not become atomic hydrogen. Helium plays two factors in your reactor. First of all, it allows you the ionization. Secondly, it stops the creation of atomic structure. You understand? Hello?
That's because it's not a higher ionization energy and so on. Is that what you mean with the helium? It's able to keep the energy levels lower?
In the fusion technology today, they tell you that we try to hit the two plasmas together, and in two plasmas coming together creates a fusion, and then you get helium, and then you get this magic amount of energy released. In fact, in nuclear structure, in the solar system, in the stars, helium plays two factors. One is in creating extreme ultraviolet, and the other factor, it stops the creation of atomic structure, because each layer of the plasma in the solar system, in a star, creates its own materials. And the beginning of the creation of material is to create, for example, hydrogen. So by presence of helium, you stop the creation of matter, because helium continuously ionizes the hydrogen, so it always stays in the state of plasma.
But then how do you explain the presence of atomic hydrogen inside the sun.
There is no atomic hydrogen inside the sun.
Oh.
These are programs written to show such a thing. This is very much the programs which nobody has looked at inside, so we have to accept this Godfather's bedtime stories. When you write a program to target such a concept, you reach such a concept. There is no atomic hydrogen. There is no. It's impossible. It's impossibility to have hydrogen within the center of the sun. You have plasmas. You have plasmas which are in the reduction. They become packages of magnetic gravitational fields that package can become an atom of hydrogen, but never reaches that state. It's the same as I explained earlier, just a few minutes ago. You have gravitational magnetic field packages of helium. You never reach atomic structure. You always reach gas structure, but in a gas status. You have packages. You don't have, you have layers of the same gravitational magnetic field, which they are of the strength of the helium. You do not achieve matter condition. The same thing is that if you the reason I explained this before in one of the talks, and the same thing as I explained in the book number 4 again, the brightness of the star is not dependent on what's happening inside it. Does not come from the center. It comes from the surface. And how it comes is dependent on the gravitational magnetic field, the strength of the inside, which interacts with the plasma strength on the top. The two, when they interact, it creates the light of the star, the brightness of the star. And if the center is very close to the surface, then you have a very bright star. If the distance between the center and outer layer or the surface is too far, you have a dimmer. So even you can have a very big star, but if the higher strength gravitational magnetic field in the near higher strength principle strength is used, you get a brighter color outside, brighter shining star outside. It all depends on the position of the star in its galaxy and its universe. So, if you understand this concept, this makes the fusion technology, which is now being done, and they say they've achieved it. It's converting energy of the plasma into the matter at the helium level. It's not a fusion. So, in the stars, we don't see, it's all combination of gases, it's combination of magnetic field of gases. And their interaction creates in layering, and those layering creates gravitational field as a totality. Because when you have different layers, each layer interacts with the one inside, further in and further in. So this creates a bigger and a stronger gravitational magnetic field. And that's why the stars are, they cover a larger span of the universe in their respect to their gravitational magnetic fields, and they can create the plasma of the solar system. And this is very clear if we look, it's in the book again, number 4, which is coming out, and I've said this before, solar systems are characteristics of the star which are on the boundary of the galaxies and not necessarily in the center, because the magnetic gravitational field in the center of the galaxies is so much that it doesn't allow the reduction so much of the gravitational magnetic field from the principal matter to the matter level that a planet or a moon can be created. You need a cooling space. You need the magnetic field reduction space. And the longer this space is, or the plasma of the star is, the more planetary system you get in. This is explained in the book number 4. So in the center of the solar system, or in the center of the galaxies, solar system, due to magnetic pressure, gravitational pressure of the other stars, do not have that much space to expand. So creation of stars for reduction in gravitational magnetic field in them is not that much that they can show planetary system. If somebody can map up the new solar systems which are getting discovered in the universe, you'll find most of them sit on the fringes or middle outwards of the galaxy. This because the pressures are not there, magnetic field, gravitational field pressures are not there, the plasma can blow bigger, very much like the balloon in the chamber, and that expansion allows the reduction in gravitational magnetic field rays from principle to matter, and that matter becomes planets and what do you call it, the moons. This is what we understand now, and it can be proven with the reactors you build. You can create matter in different layers in your reactor. You want gold, you go to closer, higher strength gravitational magnetic field in the center. Or you expand the balloon, that comes at a certain point. This is how man will create matter in the space. You want aluminium on the moon, you don't go and dig or transport aluminium from the earth. You use your reactor and you allow the certain layer to be the strength of the gravitational field of the aluminium, and you put an extraction system in it, and you literally produce continuous aluminium as much as you need. And then you have to convert the GaNs state into the matter state, and that's where your ionization chambers come into play.
That's great. Thank you very much for that information.
Could you explain the process of extract in detail? Extraction is literally physical. I've seen a guy writing me emails that you don't even know what is 4x7 and the rest of it. These people are time wasters. They're a bunch of what I call people who just spend their time in picking up numbers. In extracting gases, you have a measure of the amount of gas you fed into the chamber. Then you know the volume of your gas expansion. Then you try to go one step further in. If you're trying to extract nitrogen, you go into the carbon layer. You don't go into the nitrogen layer. You go just into the carbon layer, and then you try to extract nitrogen. Or you open a plasma hole in the nitrogen and you extract nitrogen. I've seen a lot of people making like the Chinese reactor. It was very interesting when I was watching it. They make 4 or 5 different holes for different gases. You can use these portholes for a certain point of being able to extract gases from that point. But this needs a good calculating of how much your gas expands to what layer thickness and what could be. But the other point you will understand to take into account is that when you, especially with the reactors, with the Chinese reactor and the other reactors, when you introduce these gases, part of these gas atomic structure interacts with the wall of the reactor. So you lose some of it. And on the other hand, the expansion of the plasma reduces the thickness into the pressurizing into thinner layers. So it's just by calculation. Or you use what we call antenna center core, and you go to where you want to be, you take a sip of it, you take a sample of it. If it's nitrogen, you extract the nitrogen out of it. But using gases as a blanketing, as different layers of the chamber has a lot of advantages, especially when you work at the high level or you want to use with a powerful system. Sometimes it's good to have these gases because they absorb part of the radiation which comes from the center chamber. You need it. And you find out if you can increase, for example, the gas in its own layer, not through the center column at the bottom or in the center of the reactor. You use these layers for absorbing radiation which is coming or magnetic gravitational fields which step down very rapidly to radiation level that they can harm you when you're testing. One of the points you have to remember is that when you introduce with the central column system or antenna system, if you introduce, let's say, nitrogen in the center, this nitrogen has to find its way all the way back to the boundary, outer boundary. So this disturbs your plasma. You have to make calculations beforehand that you allow your blanketing to be there all the time, or you introduce the nitrogen on an outer layer on its own to increase or reduce.
Mr. Keshe, when you're speaking of these things, is this in reference to a rotating central core, like a physically rotating sphere of some sort? Or
Any of them. Any of them. The Chinese reactor we looked at last week. Now is on the internet. The gentleman has put in feeding of the gases on the outer core, outside the core, and is connecting himself into it.
Right.
This has one advantage, which means you can reduce the nitrogen chamber directly. You say all the holes in that reactor, all the portholes in that reactor they built can be used for extraction of nitrogen, like carbon or oxygen.
But how would you extract a layer when it's not rotating? Do you mean the gases will naturally layer out in there?
The gas is always rotating. They're always rotating.
When there's a mixture of gases, it starts a natural rotating motion.
The plasma forces rotation. Once you reach a plasma, this is something you have to comprehend from the operation of your reactor. This is exactly what I said earlier on. The rotation of the solar stars is mainly created through the magnetic field gravitational layering inside them. It's dictated by it. You have no choice. This is one of the ways to create dynamic plasma. You talk about putting system outside the reactor, magnetic field, rotating magnetic fields to get a dynamic plasma. You get a dynamic plasma if you can create layers of plasma of different strength. This is how the solar systems work. The dynamic or dynamism of a star is totally due to the dynamic layer magnetic field, gravitational field of the plasma itself. You understand?
Yes, that makes sense. I keep getting mixed up between gas layers and plasma layers. I need to start.
Yeah, the thing is, the same thing. Let's say if it's very hard to go back into the matter level, if you have, let's say, water of different, let's say, salt content, different percentage of salt in it, you'll find out if you can get yourself organized with it, you get different layers of water, sweet, salt, whatever.
Right, that's one of the mechanisms that moves the oceans with the fresh water and salt water.
You get the same thing with a plasma, but in magnetic field, gravitational field strength.
Right.
The same motion is created due to different magnetic field strength.
Yeah.
So you do not need to produce external systems to rotate your reactor. You do not need to rotate the plasma. But because you need to create, you can initiate it with a mechanical system. The other way to clean up sometimes the plasma of certain layers is to do exactly what I said you can't do. You can't put like nitrogen in the center because it tries to go to the outside and it disturbs the plasma. But you can use a feeding of a plasma of a certain strength or matter inside the center is like putting air bubbles into a mud that you get the heavy materials to come up, like boiling. Yeah, you can do what I call plasma washing. It can be done, but these are what do you call it? These are very advanced levels than the people can do. If you look at the Chinese reactor, these are called monoreactors. If you look at the monoreactors of the Keshe Foundation, used to be on the front logo of the Keshe Foundation. Monoreactors, still monoreactors, are extremely beautiful to work with, but they're extremely hard because they go into the polarity change very rapidly.
What would happen in that case with the polarity change? I realize it would not be, it seems like it would not be a good thing for a gravity producing or a gravity, you know.
We lost one of our original reactors through polarity change because it had axes and the axis twisted. Twice we repaired it. The magnetic field is part of our archive materials, is part of our museum piece at the moment. And you see it used to have a pin on both sides, on either end, and it was rotating on the pin. And we created so much gravitational magnetic field, a strong field inside, that in change of polarity of the plasma, it gets a kick. And that kick, which creates like a black hole condition, twisted the axle, and that's why we lost. We can't use it anymore. It's a good museum piece.
Wow.
This one of the very first mono reactors still. Where I see the Chinese and the Polish reactors are building and the others, these are very initial reactors we built about 10 years ago.
Mm-hmm. So there's a question that just came up, for example, about that. The China's reactor, no heat generated. How to generate heat inside in their...
Why do you need to create heat?
That's a good question.
Why? You see, the heat generation comes out of the mentality of creating a steam. That you can use the steam to generate power. This is the old-fashioned thinking. But you can create heat, there is no problem. But the heat different. The creation of heat has to come from layering. Very much like the surface of the sun. You create a magnetic field of different strength inside and you put a matter, the friction between magnetic fields creates heat. Depends what temperature you want from it. The magnetic, heating system of the plasma is a very efficient way, like a furnaces of the future.
Okay, so going back to what you said, When we were discussing my reactor, you said there are no pins inside, no pipes and everything else. So how come the Chinese reactor has pipes and this and that inside?
They don't have anything inside the Chinese reactor. Everything is outside.
Yes, but there are pipes going in, as far as I can see.
No, when you look at the core, they show you the half a sphere. What I saw is a clean spheres inside. The Chinese, can we ask Mr. Cho to ask the Chinese? Because I didn't see such a thing. There is nothing inside, there's a clean surface inside.
Well, he does have a central column inside that rotates and with magnets attached to it. That was the old design. When he showed initially the reactor, he showed an empty one, and
Yeah.
and then he showed a completed one. The completed one does have a central column inside, which was not shown in the open one. He didn't show the central column, but inside the completed one, there's a central column inside.
But there is no other pipes or thing is sticking out in that reactor. It's just a central column.
Right, just a central column, and then the holes that you saw are the entry point for different gases, which goes from the bottom. Just tubes attached to the outside to feed the gas into the reactor. But the tube doesn't go inside the reactor.
No tube goes inside.
No, except the central column in the center.
Yeah, okay. Can you tell me, Mr. Cho, because when we spoke with him, I explained to him that he needs a butterfly system. So
Right.
he already has a central column system.
Yes, he has a central column, control from the bottom that rotates. He has I think a electric motor driving the central column from the bottom.
But he has a magnet in the center.
Right, attached to the central column.
Okay, one of the first things you have to do, you have to take these magnets away from the central column. This comes from the design we put on the patent.
Right, exactly.
This has misled, but this was because we had to cover every aspect of it, of the patent application.
I understand.
So, in fact, once you put magnets, you limit the operation of your reactor.
Right.
You have to remove these magnets. These magnets does not allow the creation of the plasma.
Okay, I will explain that to him. And also, what about the electric motor? Does the motor have to be removed from inside the reactor?
We lost Mr. Keshe briefly here.
Okay.
But in response to that question, I know that motors are a bit of a no-no in the vacuum environment because of the...
I lost all the communication from last talk of Mr. Cho.
Right. There was just a minute we lost here about running a motor inside of the chamber.
You cannot run a motor inside the chamber. There are 2-3 reasons for it. First of all, it disturbs the coil of the motor. Secondly, you try to have no material inside the reactor as well. If you remove the magnet, you have to remove everything else. One of the points to work with, or what I do, I make sure all the materials inside the reactor are homogeneous and the same.
Okay.
This takes a lot of technology. This takes a lot of knowledge. It's taken me years to develop this process, and that is to work with monomaterial. Because the minute you introduce, let's say, zinc and steel, or copper and zinc, you create two different gravitational magnetic field environments which disturbs the plasma.
Okay.
So you try to achieve and work with mono material inside your plasma that you get a balanced, plasma.
So the central column should also be made of stainless steel, then, just like the outer shell of the reactor, right?
Yes, but the stainless steel is one of the worst materials to use for reactor.
Okay.
I don't say because we have to let's see this, the test of the knowledge. We used to have a stainless steel, but the stainless steels are one of the most notorious materials to work with.
So what material would be better? Copper?
You can use anything, but you see, stainless steel is used in the early stage reactors. We used it. We had to wait 6 months for them to be built. People from the Keshe Foundation who were with us at that time, they can tell you, we could not get it made in Belgium. They tried all over the world to build the way we wanted it. They went to Korea, they went to China, and at the end it was manufactured in Holland. And stainless steel has a characteristics which gives a monomagnetic field plasma.
Mm-hmm.
But at the same time, you cannot do much with it. The stainless steel has a characteristics in the earth condition which plays partially because of the realignment of the atomic structure to make a stainless steel or steel that it plays. This is what I think. There is no proof of it, but that's my thought. It plays half magnetic and half non-magnetic properties. Depends which atoms have been realigned in which way. If you have a non-magnetic stainless steel, which is a high quality steel for that you can literally slide the strongest magnet on the table and it just slides like on the ice. These create certain effects on the plasma which I could not understand for years, and it took me a couple of experiments to realize steel reactors are notorious to play with if you don't know what you're doing exactly. And you see beautiful effects with it, but to get those effects you have to redesign your reactor in a specific way. The Chinese reactor is like a half pressure cooker. This reactor will have a problem with plasma control, especially with the lift, because the bottom half is flatter than the top half, and the plasma tends to run up north side of when you go to the top, because the pressure underneath will not create it's a two-layer system. Two-layer system internally we tested in Tehran, and these have vibration problem. Your reactor has to be half or two similar halves attached to each other. The way the Chinese reactor is will create control problem in the future. That's what we've seen. I hope I'm wrong, but you see a lot of vibration because the plasma becomes two separate plasmas, one which operates in the bottom and one which operates on the top, or a plasma takes the shape and as it's like an arrow, most of the plasma pushes pressure on the top, and it's like squeezing a cream extract, the when you decorate the cake with a cloth and it comes out in different shape. You pressurize the plasma to the top side. But if you can create two layers on the bottom half and the top half, these create a lot of vibration. I have a reactor which is designed this way especially. But these reactors can be used for material production because you can create interface where you can extract what you need from it, deliberate extraction.
in the Chinese reactor, what kind of things that we should do now, just for experimental?
Let them test. Let them test. It's a nice experiment because he has two very interesting points, and that's why I asked to put it on. First of all, he's come up with freezing the gas with nitrogen, and secondly, he's irradiating the gas before it enters. This is very much like upper atmosphere condition, and it's very interesting to see what results he gets and what we can report later on.
So he should at least remove the magnet and the motor. What about the central column? Should he remove the complete central column altogether?
No. You can use the central column. You can use it. Or, because I have central column reactors. I've had central column reactors for years. Central column are very good for testing different things. Because if you look at one of the pictures of the Keshe Foundation reactors about 5 or 6 years ago, you see copper rings, 3 different copper rings on the central column outside.
Mm-hmm.
These copper rings are connected internally in different points in the reactor in the central column.
Okay.
This has taught us a lot of things about the behavior of plasma and the gases inside. Because you measure the difference in the current, you measure difference in temperature through these connections. And then you see the layering. You understand which layer you're in. These are part of the technology development experiments. So we done such a thing. So, and
Mr. Keshe, is that like a brush type connection you're talking about on the rings of your reactor that to pick up?
Yes, exactly. This was done to test the reactor plasma behavior inside.
I see. Now, on your reactor that we saw during the peace treaty and so on, that was presented, the new one that's the non-radioactive, there seemed to be rings on that reactor as well, but they were used as belt drives for motors, it seemed like. Was there an internal...
There is no such a thing on the new reactor. The belt drive is for a different purpose. This reactor is built in a very specific way for specific conditions, not to use nuclear material. That's why the testing of it is taking so long. The motors which you see on this new design is for creation of non-nuclear condition ionization. It's interesting enough, when we received the rejection letter from the nuclear inspection of the Belgian government, they said to me, you can create the plasma without use of nuclear material. And I said to them, can you come and show me? But they couldn't do so. So I set out to do it in a different way. A plasma can be created non-nuclear, but if you're creating a plasma for gravitational, you need a nuclear material. So it depends on what you define a plasma as. You need the central column in a certain ways, and then you need to add the materials to it or create the condition of the center of the solar system, center of a star, to achieve continuous plasma without creation of atomic structure. Your biggest problem is creating atoms in these reactors now, especially with non-nuclear. Because once you create atom, they absorb the plasma and the plasma just collapses.
How do you create the plasma besides by drawing it to a very low vacuum? That's the only way, right?
What do you mean?
By keeping the gas at an extremely high vacuum state, then you convert itself into the plasma, right? Instead of the atomic structure.
What you actually do, if you can control the Chinese gas measurement I saw on the machine, and I've seen that with another system, these are too much gases.
Right.
These are far, far too much.
Right.
When you introduce very, very little amount of gas,
Mm-hmm.
then, as you said, you create a vacuum, and then that vacuum allows the opening, the separation.
So let's say, for example, if you have 10 centimeters globe, how much gas supposed to go inside?
Very, very little.
Which means what?
I
5
do a different measurement because that's how I set it out to do. My law is the law of universe. The law of universe is conditions are created according to what's available at that time in that position in the universe. So I create the condition. I don't create the reactor. I don't make the reactor. I create the condition. When you create the condition, you achieve what you want. So the way I usually work, and it's the best way I know, without all these sophisticated measuring tools, is I get a 4 millimeter tube or 6 millimeter tube, and I cut it to a certain size, 2 centimeter, 3 centimeter, and that is my measurement tool. How much gas do you get in 1 centimeter of 6 millimeter tube? You fill it in, you close the top, you close the back pressure, you open it, that's the measure of the gas which goes in.
Yeah, that's pretty similar to the system I have.
So
I have 3 centimeters tube, 4 millimeters inside
3
diameter.
is too long.
3 centimeters is too long.
It's too much. This sophisticated system I've seen with the Chinese is fantastic. These are good when you go into the control system. High performance condition.
So 3 centimeters is too much for all the gases or just for
All
a
the
single?
gases. All the gases.
Wow.
Yeah, because don't forget, Mr. Ludwig, the 3 centimeter of hydrogen gives you a higher number of atoms than 3 centimeters of nitrogen.
I didn't catch that.
The number of atoms in 3 centimeter of hydrogen is more than the number of atoms of nitrogen. It's atomic weight, atomic volume, you can measure it. So then you find out you have too much hydrogen atoms in your plasma, in your core. So you get stagnation. You don't get ionization. Or you get ionization just on the interface with the nitrogen if you are using radioactive material substances. Your nitrogen layer has to be very, 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 very thin, but thick enough that it can allow if you fix radioactive material on this inner core, or your internal cores, that can ionize enough nitrogen to release, not ionize nitrogen, but to cause the release of extreme ultraviolet to ionize the hydrogen. So if you have a huge amount of hydrogen, only your top layer interface with nitrogen gets ionized, then you have problem.
Okay,
Because
so
the plasma will go into the center, and in trying to go to the center, it loses its plasma condition because its energy and its magnetic field gets absorbed by the other atom of hydrogen in the chamber. It's a very tricky, but you have to find a way to create to feed as minimum as possible hydrogen into your chamber, but enough that after losing some of the fields to the structure, you have still enough plasma. Central column is a useless thing. You don't need a central column. If you can create a dynamic plasma condition layering.
Without the central column.
Without central column. There is no central column in the Earth, there is no central column in the Sun.
And without rotation as well, Mr. Keshe?
You create rotation through plasma layering, magnetic field strength layering.
Okay.
okay, so
We test a lot of central core. We test a lot of central core system because these are very interesting in monitoring plasma behavior.
Would a glass globe be one of the better ways to be able to observe that and have it happen?
Can you see nitrogen through a glass plasma, glass tube? We can't see the layers.
Right. But we could see any interactions that might occur through scintillation.
If you have a window, you see a lot of coloring. The people who made the multi-cores, or if you can place another core inside your core, you will see the effect of plasma very, very clearly. Because when you create a certain strength plasma in your inner chamber, and then you keep that as a constant, and then you play with the gravitational magnetic field of other chamber. For example, let's say your core is rotating at, let's say, 1,000 RPM. As you change the plasma thickness and the strength in your outer core, you'll see that the core comes to a standstill because the magnetic gravitational field inside in the inner core, even though it's smaller, becomes balanced with the magnetic gravitational field in the outer core. And I have sat for hours wondering when this thing is going to go. And then out of nowhere, it starts rotating again. When the misbalance comes to operation, you find out you see that your center reactor, center core, it starts rotating. This is magnetic plasma strength layering. And then you can sit there. The first time I thought there was something wrong, and I was sitting there and I was thinking, my God, what's happening? What have I done wrong? Why has the system has broken down? The motor burnt out. I tested everything, but there was nothing.
It was actually in balance, right?
It was imbalance, yeah. This is magnetic gravitational field layering of plasma in balance with each other. Even though your center core, what you call the Caroline core, is much smaller in volume, but because you reach ionization and then you reach a plasma condition in a specific strength, when it becomes balanced with outside, the motor stops. And then, if you have a right mixture and you have a window, you start seeing color rainbow. The color rainbow is when you see colors you never seen before. These are the interaction of the transition strength into matter when they slow down. You see this through the window. If you have a glass chamber, the way you're talking about, it must be a fantastic view to sit and watch.
Okay, so another question. There is a guy which is able to produce a globe, and if we take the amounts of the gases from the patent and we are able to ask him to fill the globe with it, is that gonna help to achieve the results?
You can achieve all sorts of things with different systems. As always say, the Chinese system was fantastic. The way the guy has come up with the concept, reading the same pattern by freezing the gases. This goes back to what I said in Bulgaria. There are as many different ways of creating gravitational magnetic field as there are stars in the universe. You have to find out how your system does work.
Well, that's the problem. So far doesn't work, so I'm trying to get it working in order to be able to expand
You
my
have
knowledge.
to, you got to have two things in mind. As I've seen in the reactors, you have to keep a clear distinction between matter and plasma. The other thing is you have to understand that the plasma has different strength and different layering itself. So if you understand the two big differences, then you can start playing all sorts of things with reactors. You are trying to do something which is you have half of the thing and you hope you achieve the whole thing. You have not achieved the full understanding of the gas separation, plasma separation, creation of plasma with two gases, not four gases or three gases. This needs mature. The more you test, the more you understand. This is how we do it. This is how I learned to do things. Now we are, because of the amount of time I spend in development, I'm a few steps ahead of you. And I'm only a step ahead of you in the materials and the systems I have tested. That's why I don't say to nobody your system is wrong. That's why I encourage the different developers to carry on their way, because they have found their way, they see their method, and I'm not 100% right in in criticizing or nothing to say because I've developed the technology it's got to be my way. No, this is the open technology. You have to find what you're comfortable with and what you can add to the knowledge of man. So if you cannot achieve through your system, most probably you will still have to understand the difference between the plasma and the matter condition, and then you have to understand the difference between the plasma layers. It's as I said to our Chinese guys, take the magnet out. Magnet creates condition of Earth only. When you add magnet in the central column or in your center of your reactor, then you enforce Earth's gravitational condition, because iron is magnetic only in the Earth's gravitational magnetic field condition. Iron is not magnetic in another solar system. So when you put magnets, you enforce a condition and you freeze it. This is what I try to explain. When you use a universal magnets, which are a totally different concept, then you can have magnets according to the environment you're in. Now we use universal magnets. This is a very advanced knowledge. It takes a lot of experience and it needs a specific process. When you put magnets, solid magnets, inside your reactor, as I said to our Chinese guys to redraw it, you enforce, you freeze, you condition your reactor to the atomic structure of Earth condition or the solar system condition. Iron is not magnetic in another solar system. So Well, now I have developed what I call universal magnetic system. If you are in this solar system, in another solar system, in another universe, in another position in this universe, it still works. This is how what you call UFOs work. They don't change characteristics according to the environment to where they come to Earth. The system itself, because of its structure, adapts itself to any environment. And this is the backbone of the new non-nuclear reactors, non-radioactive reactors which we develop. And it's not visible, you cannot see it, it's not tangible, you cannot hold it, but because the condition I create now in my reactor, I can operate on Earth, I can operate in the Moon, I can operate in the next solar system, you can go from one galaxy to another, one planet to another. That's why we put this magnet in our pattern, not to mislead, but to cover the essentials of the pattern that we cover everything. And that has been the biggest problem. Initially, in some of the reactors, we used what are called confusion magnets. Confusion magnets allows the balanced magnetic field, but then we dictated the condition of the reactor and we have to withdraw it. What I call confusion magnets is when you take a magnet and two magnets and you stick together. If you get a spherical magnet, or what do you call it, circular magnets, you can't put them together unless you turn the other one. So what I call is confuses the magnetic field, but you still condition your reactors into the Earth condition. The structure, that's why the new reactor has taken so long to develop. And when I said in the presentation of the 21st, that this reactor can give you everything you like, and people laughed, and I had a lot of emails, a lot of nonsense people who don't have a clue about physics. They're saying, you talk about this and that. No, because now we're going to step further. You do not have Earth condition. You cannot use solid magnets. You cannot use whatever combination of magnets you use in your reactor. That way you condition yourself to Earth conditions, atomic magnetic gravitational field. So you have to find out how your system works, and you have to design a reactor which is not conditioned to Earth. So using or saying, I'm wrong, you told me this, no. I just see what we've done according to what we understand and generally to what applies in the universal condition. The universal magnets are amazing. They have a property which is non-tangible, but it gives you every condition you need. So we'll test this very soon and we confirm the correctness.
Mr. Keshe, so you mentioned earlier that it's better to just use two gas to start with. What two gases do you recommend? Is it hydrogen and helium?
I use different things. I use even three gases, but if you use helium, you 100%, or with the present knowledge what's in the forum, you need radioactive materials.
Okay, that's fine.
So,
I mean, for experimental reasons, we can try with americium 214.
yeah, but then you need a large number of it.
A large number of it. Okay.
Yeah, because one of the problems you will have, americium, usually if you take it, let's say, from smoke detectors.
Right.
These are encased in lead or encased in different materials,
Okay.
which are directional. And these casings absorbs, it literally sucks in the plasma to itself. So you create ionization, but the material of the what do you call it, of the casing or where they put it in creates that kind of thing. Some people use the small sheet of it, or what do you call it, the spots of it, without the casing. Then you have a radiation problem. And then secondly, alpha radiation has a very limited range. And then you have to calculate your gases and the condition of the gases and the angle of the gases, of the, what do you call it, the radioactive material. It's a very tricky point, and then you get the radiation, depends how you handle it. With this new technology we developed, all this comes through the window.
So if we're going to use two gases, which two would you recommend? Is it hydrogen and nitrogen then?
You can use hydrogen, nitrogen. You can use, if you use hydrogen, nitrogen, initially as you are testing, use a heavier gas like a carbon as a third layer. That to absorb any radiation or any damage to, because one of the problems you will have is that you open these reactors to get into it or to change things, yeah?
Mm-hmm.
You don't want to contaminate your walls.
Okay. You said, when you said carbon, do you mean carbon dioxide or carbon gas? Because it's very difficult.
Carbon gas.
Carbon gas only exists at very high temperature, though.
No, there is a way you can create it. Or you can, if you use a CO2, when you open your reactor, you'll see moisture.
Okay.
Yeah. I have used oxygen as a layer. Don't forget, I test everything, like we had the opportunity to do. If you use oxygen, you have a problem with limitation. So what I use in testing condition is a hydrogen, helium, and nitrogen. But nitrogen as a blanketing, not as an ionization layer.
Okay. And then you think that butterfly stirrer still should be placed from the top inside?
Yeah, but your butterfly has to sit as close as possible to the wall, external wall.
Oh, I see. Not at the center, but towards the wall.
No. If you use it at the center, then you create yourself a huge problem.
Okay.
Because then you separate the two plasmas, like the Chinese reactor, in two different halves. You literally, like a knife, you cut the plasma in half. And then you create two different field strengths, because your material in your reactor, top and bottom, is not homogeneous. You most probably have a motor running outside which attracts the field in different direction. Then you have a huge problem. The butterfly has to be as close as possible, few even micron or millimeter maximum away from the wall, and it's very hard to control because it opens up in different ways.
So the butterfly stirrer at the top should be close to the wall.
As close as possible, yeah.
Okay, and it just rotates, right? It just stirs the gas inside.
No, in a way, yeah, it doesn't stir the gas. It rotates the gas. If you put it in the middle, it will stir it. If you put it against the wall, it creates a dynamic gas, dynamic plasma.
And what RPM should we rotate the butterfly stirrer?
You can do that anything. Depends on what vacuum condition you work and what mixture you work.
Now it's going to be very difficult.
10,000. I have done up to 10,000.
Oh, never up. So 10,000 is too high. What you mean is?
Yeah, I've done it, but it doesn't. It creates a compression of the plasma because when you do external butterfly, or what I call the external butterfly near the wall,
Mm-hmm.
you have to do it from both ends.
What do you mean both ends?
If you have a sphere, you can't just do it from one end.
Oh, I see. Okay, I got it.
Yeah.
But this,
Our butterfly system is got to be on both ends of you, and then the speed and synchronization has to be the same. Or you use a half a sphere plasma. What do you call it? Reactor.
Got it. Now the Chinese reactor is only half a circle, a semi-circle, so he can just do it on one end, right?
My suggestion to him is put a plate under the half. The way he has it, he has two halves. The bottom half is very much like a cooking pot.
Right.
He puts his sphere on top of it.
Uh-huh.
He needs to put a plate in between the two.
So to make it a perfectly half hemisphere, what you mean is?
Yeah. But these are very good for lift conditions.
Yeah. Okay.
But he can
now,
use, if he join the two, if he's got two halves and join them together, it's much better.
Yeah, but for initial testing purposes, do you think he should just start with a full sphere or half a sphere would be sufficient?
He can do both, you get the same results.
Same result, huh?
Yeah, because if you look at the design of the black reactors we've shown for years, it's half a sphere. If you've been to the presentations where we have shown the Iranian space reactor, spaceship reactor, it's done in that kind of combination. The Iranian spaceship program, what do you call it, the reactor initially is that kind of a structure. And it shows to be very efficient for lift. Okay.
Now, how do you recommend that he insulate for the butterfly stirrer, the axis going into the reactor from the outside needs to have
he's done his rotate his central column. Something maybe it's good for people who are trying to set up vacuum condition. Is use like 1 bar rings. If you use, I was discussing this with the Polish team. If you use multiple sealing rings, like 0.7, which is the easiest, cheapest you can buy in the market. If you put 2 or 3 of them in the central column axis, between the first and the second, you can go up to -4 or 5 bars. Between the second and the third, you can go up to -9 bars. So, in a very cheap way, you can maintain a very high vacuum condition. And you only need to separate them by about 0.5 millimeter. You can use, with a minimum friction, high fast rotation of butterfly.
Okay. I will explain all the things that you told me to him.
If you take up, let's say, the butterfly is on a stick which goes in the core, yeah?
Right.
You use a vacuum seal immediately at the entrance of the core. You have to hide it, that it doesn't create a different material condition. And then about, let's say, half a centimeter above that ring towards outside, towards your motor, you put another ring. Between the core, center core, or your reactor and the first ring, you can reach, let's say, 0.7, less than -1 bar. And then, when you put the second one, you go to -4. And then if you put the third one, you go to -9. So you can keep the central chamber at a very high vacuum without ever interfering with outside. And the friction is very, very little because you can use vacuum oil or vacuum grease to reduce the friction to minimum on your motor.
Okay.
Vacuum oils allow you high temperature resistance between the ring and the wall of the, what do you call it, the shaft where you put the ring in. If you use oil, certain oils, if you have a good access to vacuum grease, the vacuum oil, that gives you a very good, more or less, very high performance rotation.
Got it. Thank you.
Okay. What's the next question? Have you heard about Donald Smith generator? No. So each layer contains only one type of gas. Yes. Chinese I can't read. Mr. Wang wants to know the way to activate the reactor. We explained this one. It says, do you use CS as a metallic vapor? What's the CS?
Cesium? That would be cesium, I believe.
Are we sure?
Well, according to the table of elements, isn't it CS for cesium?
But it says a metallic vapor.
Yes, right. That's the idea. Is like, for example, in the animation of the Chinese reactor, you see the potassium being entered as in a nano, what's called nanopotassium, and others have thought of a diffusion of gas like cesium or
well, it says a metallic vapor.
right. The idea, there's another question further down, and it gets into the idea of you have a filament basically that you heat up, and the element is on it, and it would tend to vaporize. It could be.
Yeah, no, I don't see it that way. You can use much more effective radioactive materials which are always stay in the state of gas. There are gases and isotopes which you can do so. Because when you use Weber metallic materials, they will stick at the end of the day. They interfere with the plasma, and then they stick to the wall of the reactor.
So, it seems like the radioactive gases are one of the best ways to get things going, but it's not.
No, yes, at the moment with the knowledge you have, yes. But with the knowledge which we put together now with the non-radioactive material reactors,
Right.
you don't need it. We will announce this very soon if the test comes out. We should start testing in July. In July, August, the reactor should be ready to go for test. And then we most probably will show a lot of things like this.
That's great. I did have one concept of a reactor that would collect the radon gas that's available in most of the basements of in North America and all over the world. It turns out that there's radon gas is collected because of the design of the foundation of homes. Basically, collects the heavy radon gas in the basement, and it becomes an actual second leading cause of lung cancer in the world, behind tobacco. And it might be a way to collect that gas so that it's not given off into the house. Most people, to ameliorate it, they actually put in a fan system to collect and pump the radon gas through their home through a pipe and out through around where the chimney is. Then the gas, I guess, flows over the roof of their house and back into the bedroom window, and it's not a very good way to get rid of it, in my estimation. But so I think, why not collect it and have it be accumulated in a reactor that can use it and actually increase the potency or power of the reactor over time, or enable it to continue on its own just through the relatively trace amounts of radon gas, but enough that it's significant. It might be accumulated in a reactor setting, at least in some homes that have the higher rates of the gas accumulating. Does that sound a little far-fetched, or is it?
No, really, try it. It's a very interesting concept.
Because then you could sell the reactor as a radon gas, what do you call it, collector or amelioration device.
Self-powered.
It's a solution to that problem. And you just happen to have a couple of electrical outlets on the side that you can plug your house and car into at the same time. That's just a side benefit from the primary purpose of the reactor, according to the way you present it to the government and so on. It saves lives would be the idea, the concept behind it. Because, like I said, I think radon gas is I believe it's how my father died, for example, and I think it's important that people know more about that. It's not something we hear of all the time, but yet it is a major issue that they sort of want to just keep quiet. Anyway, I thought I'd throw that in as a...
Yeah, it's a good concept. It's like the Chinese freezing what do you call it? Using nitrogen gas to cool the gas down.
Yes.
The helium for it runs.
And in that respect, do you think that if you're going to do that, would you want to have the very cold gas going into the reactor? And since it's the scintillation, the way I understand it, it only occurs for a short period of time, like 10 seconds or something like that. Is that true with the helium as it goes through the radioactive source? And if so, shouldn't the line be short going into the reactor from the liquid nitrogen cooling situation?
I don't know. That's why I'm interested to see what they do, how it comes. How much of it can they get into the system?
Right.
It's unusual phenomena, but that's how they read the pattern. That's what they understood. It's very interesting. But in fact, this is how, as I said before, happens in the upper atmosphere. I'm literally very interested. I look very closely at this Chinese test. It will teach us a lot of new things, because it's the first time somebody has built a system.
Yes, he's actually using gases and trying to do it the way it's supposed to be done. That's encouraging to see.
I hear from Maltese guys that they are coming up with a new reactor, if I understand correctly from their communication, and their approach is different. Now, as I said, we got about 30 different nations plus now who are building their own ways and testing. And we will see that a lot of them are keeping away from public view because of maybe being embarrassed if it doesn't work or something is wrong. Where people start coming out and showing their way, and even we see things, we cannot show it. That's why I asked Mr. Cho to ask the Chinese team if we can show their video. We know a lot of people are doing development, but we are not allowed to speak or to show them. And each one of them are coming with new concepts, new designs. one of the very first people who read our patent and started developing is MIT and University of California. Some 5-6 years ago, they started developing because they sent us a copy of the reactor they built, the pictures of it. And they are very, very much in advanced level in testing, but they don't talk about it. It's the same with NASA. NASA is developing their own concept because they received the key and they immediately start working on it. And part of the American Navy in 1970s tried to do such a thing, but with solid magnets. But they never understood, as I said before, the solid magnet limits the creation of gravitational fields to the Earth condition, and then it has all sorts of problems, inherent problems of the condition. It says, how do you activate the new reactor being tested? That's our secret.
Could you say that again? I couldn't quite.
There is a question at 629. It says, how do you activate the new reactor being tested? I said, that's our secret. When we tell you later on, you'll find out.
That keeps us coming back for more.
No, but we have to test to see we are correct.
Yes, right, absolutely. I find that there's a tendency for folks, especially the ones that aren't actually doing the testing and trying to build a reactor and so on, to say, well, why don't you release it quicker, faster? Why not now? Why not right away? And you're deliberately holding back information and so on and so forth.
We are holding back a lot of information. Of course we do. That's our right.
We have to, because...
Right. This is our right. If you have it, you do it. We are holding enormous amount of information back. Enormous amount. You are not getting even 1% of what we developed and what we are developing.
Right. So in that sense, there was a question about, we've heard that the USB key was given to the governments of the world. And the way the person asking the question presented it was, well, why not give all of us, like experimenters and other ordinary people in the world or whatever, the same information that's on the USB key and so on, and supposedly release it to the general population. Can you address that question a little bit?
What are you trying to ask me?
Well, I guess there's some people that seem to want all the information, that things are being hidden or not being given to the people, that it was given. There's this attitude that it's been given to the governments, but that's kind of, the governments could be corrupt and blah, blah, blah. So why not, it should be given, if it's free energy. I know you say there's no such thing as free energy. If it's free energy, it should be given to the people so that, we can supposedly work with it. I don't agree with that myself, but this is an attitude or an idea that's come up from time to time.
Yes, in a way they can say whatever they like. In a way, it's not our job. In so many ways, with the development of the new reactor getting tested, that makes a lot of the things, even in the USB stick given to governments, obsolete.